Read all. In this video, we are going to see how the block diagram reduction techniques has been involved in control system. So one of the important parameter while considering a control system is block diagram reduction, because we are using lot of signals for taking input signal. So in this case, we are going to reduce the number of blocks based on the properties. So while considering the block diagram reduction, so we are going to consider input and output and transfer function of the corresponding systems. So here we are going to see some basic elements of block diagrams. So G of S is input controller and H of S is a feedback system, and R of S is input and C of S will be output signal. So in between these two terminals only we are going to reduce the number of blocks. So these are some of the examples of blocks while adding the control systems. G of S is input signals. Input signal we are going to give. G of S is act as a controller. So output will become Y of S equal to X of S into G of S. Summing point A plus B plus. So Y equal to A plus B. So while considering this this summing point, we have to consider A plus and B will be a minus. So A minus B. So likewise, we are going to identify the basic elements of the block diagrams. In this case, we are going to see how the block diagrams has been reduced by using this reduction techniques. So we are going to see some properties of the block diagram reduction techniques. So initially, we are combining the blocks G1 into Z2. So if you are consider the two blocks, we can combine by using this G1 into G2 multiplication, so that we can take it as only one block in this equivalent diagram. Next one is combining parallel blocks. If it is in parallel mode, then we are going to take it as G1 plus G2 additional. If it is moving from one branch to other branch, we have to consider like this, because we are going to move from X1 to ahead of the G1 block, so that it will comes from 1 by G1. Next one is moving a branch point before the block. So branch point is above after G1. This branch point can move towards the G1 can be possible by G1 block, because it is moved towards the G1. So we have to consider G1 block again. Next one is moving the summing point ahead of the block. So because in most of the problems or closed loop problems, we have to move towards the branch point, move towards the summing points before the branch point. So it can be calculated by using this above equivalent diagram. So G, we have to move towards the summing point after the block. So G summing point, because we have to move from before G to after G. So we are consider G block again. So moving the summing point before the block, the same problem, the same concept will be executed here also, because here we are going to take right side of the concerned block. So here we are going to move the left side of the block. So it will be considered like above examples. Next one is elimination of feedback block, because it is one of the factor we are going to reduce the number of block diagrams. So in order to eliminate the feedback of the summing point, we have to consider like G by 1 plus H, because we have to eliminate this block H by G by 1 plus, because already it is known that plus or minus, so we have to consider plus or minus. So G into H, because it is a multiplication product, because we are going to give the output towards the end by using this block feedback block. So G into H, G by 1 plus or minus G into H. So here we are going to consider how the combination blocks and moving summing point in a real-time block diagram reduction. So G1 into Z2, G1, G2, if it is parallel, G1 plus G2. Moving summing point, we are going to consider the block by using this above principles. So likewise, all the examples already we have discussed in the properties. Thank you.